let's look at how to solve partial fractions with repeated factors. Repeated factors is basically when any value or variable in our denominator has a power greater than 1. So here we have x and it has a power greater than 1. So how you factor it is basically first you will write it with power 1. And then you will just proceed and keep adding plus 1 to the power till you have reached the power that we have. Like for example, if we had 3 here, then we would write it like this. But for simplicity, let's just solve it with a 2 power. So here we just need to write it like this. And then we write this equation simply like we did before. Now let's multiply the denominator on both hand sides. Here it would cancel out obviously. In here if you multiply this by the first fraction, this power would cancel out and we would be left with a multiplied by x minus 1, and if you multiply this by this fraction, the x square would cancel out and we would get px minus 1. In here x minus 1 would cancel out, so you would get cx squared. Now open the brackets and solve the right hand side. You'd get a x squared minus ax plus bx minus b plus cx squared. Now we need to separate out different powers. So we take the highest power first. For the highest power we have ax squared and cx squared. So we will write this as a plus c x squared. Now we take x, we have ax, bx here, minus ax. So we write minus a here, plus b here, and we will write for x. And for the constant we only have b. So we write minus b here. Now we compare right hand side to left hand side. For x squared we don't have any x squared here, so we can write this like this. Basically to make it more clear, we don't have any x squared here, so we would write as 0 is equal to a plus c. Here we took the coefficient of x squared and here we took the coefficient x squared. So this is our equation A. And then we will take for x, we have 2 here coefficient of x, and we have minus a plus b. So we would write this like this, and this is our equation B. And then we have 3 here as constant and minus b here as constant. So this is our equation C. Now we can take any of these equations and solve for the values of a, b and c. So here if we add these two equations, we can get the value of a because these would cancel out. So we would add these and then our b's would cancel out. We would get, if we add these, then we would get 5 here minus a here. So our a would be, we take the minus to the other side, a would be minus 5. So we have a value of a. Now we would plug it in this and we will get the value of c. C is 5 and b was 3. We don't even need to solve for this. So minus 3. Now we can just plug these values into our equation we wrote here. So we can just write this as 2x plus 3 over x squared x minus 1 equal to our a here. We would replace our a here. Then we get x, and we would replace our b here, and we would get minus 3 over x squared, and we would replace our c here, and we would get 5 over x minus 1. So that was it for how to solve partial fractions for repeated vectors. Now let's see how we would solve it for irreducible quadratic vectors. Let's solve it for that. Let's take an example. We can take this example, x plus 2 x squared. I'm making it more complicated so we can practice once. So this is linear, so we would just write it like we do, x plus 2. And this is not linear, this has a power of 2. So we cannot write it simply like a. So when you have a polynomial, when you have a variable which has a power greater than 1, then you write it like this. Then you add an x in the numerator, and then you simply write the denominator as it is. Now we would multiply both hand sides by the denominator, and this would cancel out.